A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Herman, I was looking at my browser's task manager this morning, and it occurred to me that we are living through a total inversion of how the internet actually works. For 30 years, the browser was just this thin window, right? A document viewer that begged a server somewhere else to do all the heavy lifting. But today, the browser is starting to look more like a heavy-duty operating system that just happens to display websites on the side. It is no longer just a portal. It is the primary runtime for local private AI agents.
It is the ultimate platform shift, Corn. And it is funny you mention that because our housemate Daniel sent us a fascinating audio prompt this morning about exactly this. Herman Poppleberry here, by the way, for those joining us for episode 1061. Daniel was pointing back to our previous discussion on the Model Context Protocol, specifically the Web MCP pilot that Google has been running. He wants us to dig into the reality of client-side AI, not the hypothetical future, but the stuff happening right now in March 2026 that is making the DIY local AI scene look like a very different beast than it was even a year ago.
It is a great prompt because it hits on that friction we all feel. Most people want the privacy of local AI, but they do not want to spend their weekend troubleshooting Python environments or managing Hugging Face cache folders. Daniel's question is basically, is the browser finally the Trojan horse that brings local large language models to the masses without the technical headache? We are seeing Google's Web MCP initiative move from a niche developer experiment to something that is fundamentally changing how the average user interacts with the web.
I think it is. If you look at what has happened since that January 2026 Chrome AI Core update, the landscape has shifted from what we used to call Bring Your Own Model, or BYOM, to what I call Browser Cached Models, or BCM. We are moving away from the era where you had to be a hobbyist to run a 7 billion parameter model on your machine. Now, it is just becoming part of the plumbing of the web. This is the sequel to episode 855, where we first introduced the concept of the agentic internet. We are moving from the vision to the implementation.
That is the perfect way to frame it. Today we are going to break down how this is actually working under the hood. We will look at WebGPU and WebNN, which are the real heroes here, and we will talk about why this might actually be the end of the DIY era for a lot of people. We will also touch on the security implications, because as we always say, if you are not running it locally, you do not really own the data. But before we get into the weeds, Herman, let us define the shift. Where we talk about WebMCP standardizing how browsers expose local tools to LLMs, what does that actually look like for the person sitting at their desk?
In the old world, if you wanted an AI to help you, the website sent your data to a server. In the WebMCP world, the website asks your browser if it has the tools and the brains to handle the request locally. The browser acts as a mediator. It says, hey, I have a cached version of Gemini Nano or a quantized Llama 3.3 right here in the system cache. I also have access to the user's local file system and calendar through these secure APIs. I will run the inference here, and the website only gets the result. It turns the browser into a high-security vault that also happens to be a supercomputer.
So let us start with the mechanics. Herman, you've been diving into the technical specifications of the recent WebNN releases. Most people hear browser AI and they think of those slow, clunky JavaScript demos from 5 years ago. What has actually changed in the last few months to make this viable for real work?
The biggest change is the bypass. Historically, if you wanted to do anything intensive in a browser, you were fighting against the fact that JavaScript is high-level and relatively slow for math. But WebGPU changed the game by giving the browser direct, low-level access to the graphics card. It is not just about drawing frames in a game anymore, it is about parallel processing. But the real breakthrough, and what Google really pushed with the Chrome AI Core update in January 2026, is WebNN, or Web Neural Network.
And just to clarify for everyone, WebNN is different from WebGPU because it is specifically optimized for deep learning operations, right? It is not just a general-purpose graphics tool.
Think of WebGPU as the broad highway and WebNN as the dedicated high-speed express lane specifically built for tensors. WebNN allows the browser to talk directly to the hardware acceleration on your chip, whether that is an NVIDIA graphics card, an Apple Silicon Neural Engine, or an Intel NPU. It bypasses all that translation layer overhead that used to make browser-based AI feel like it was running through molasses. It is using the same silicon instructions that a native C++ app would use.
I saw a benchmark recently comparing a quantized Llama 3 model running in a standard Chrome window versus running it through a dedicated local environment like LM Studio. A year ago, the dedicated app would have crushed the browser. But now we are seeing near parity. On a modern M4 Mac or a high-end Snapdragon X Elite laptop, we are seeing speeds of 30 to 40 tokens per second right in the browser tab. In some cases, because of how well the browser handles memory scheduling now, the browser is actually more responsive for short bursts of inference.
That is the magic of the model caching initiative Daniel mentioned. See, the biggest barrier to entry for local AI has always been the download and the setup. If a website says, hey, I can help you summarize this document privately, but first you need to download 4 gigabytes of weights and configure your drivers, 99% of users are going to hit the back button. That is the restart tax we talked about in episode 1076.
Right. It is the friction. There is a download tax and a configuration tax.
But with the new browser native caching, the browser itself manages those model weights using something called the Origin Private File System. It treats a large language model like a shared resource. Imagine if every single app on your phone had to download its own copy of the English dictionary. That would be insane. But that is how local AI used to work. Now, with WebMCP and the AI core, the browser downloads a high-quality quantized base model once. It sits in a protected, persistent cache that is shared across origins. Then, any website or agent you authorize can call upon that model without you having to download it again.
That is a massive shift in the user experience. But I have to ask about the memory overhead. We talked about this in episode 633, the memory wars. If I have 50 tabs open, which I usually do, and one of them is running a local model, is my entire system going to crawl to a halt? How is the browser managing the VRAM without crashing everything else?
That is actually where the most interesting engineering is happening right now. The browsers are implementing what is essentially an AI hypervisor. When you are not actively querying the model, the weights can be compressed or even partially swapped out of active VRAM to the system RAM, and then pulled back in milliseconds when needed. It is much more efficient than having 5 different Electron apps all trying to hog 4 gigabytes of VRAM each. The browser acts as the single source of truth for hardware allocation. It can prioritize the active tab and throttle background inference to ensure the UI stays buttery smooth.
It makes so much sense from a resource management perspective. It is like the browser is finally taking its job as an operating system seriously. But let us talk about the security side of this, because that is a huge part of the WebMCP promise. In the old world, if I wanted an AI agent to help me with my email, I basically had to give a cloud provider like OpenAI or Google access to my entire inbox. My data leaves my house, goes to their server, and I just have to trust their privacy policy.
It is the ultimate act of faith, and for a lot of us, it is a bridge too far, especially with the way data harvesting has trended in the last few years. But when the model is cached in your browser, the data never leaves the sandbox. This is the sandboxed execution model.
Right, and this is the key. The browser sandbox is one of the most battle-tested security environments in history. We trust it with our bank logins and our private keys every day. By moving the AI inference inside that sandbox, you are creating a wall. The model can see your data to process it, but the website providing the interface does not necessarily have to see the raw data. The WebMCP standard allows the browser to say, I will perform this task on the user's data using my local model, and I will only return the specific answer the website requested.
You can have an agentic workflow where the browser says, okay, I will let this tool look at your calendar to find a meeting time, but I am doing the processing locally using my cached model. The only thing that gets sent back to the web is the final result, like a calendar invite. Your entire history of meetings stays on your local machine. It turns the browser into a privacy shield rather than a data funnel. It is inherently safer than piping data to third-party API endpoints because the attack surface is limited to your local hardware.
I think people underestimate how much that is going to change the enterprise side of things too. Think about a lawyer or a doctor. They cannot just upload client files to a random cloud LLM. But if they can use a browser-based tool where the weights are verified and the execution is local, the compliance hurdles almost disappear. It is a game changer for professional standards. But it also leads to what Daniel asked about in his prompt. Is this the end of the DIY era? If the browser makes it this easy, why would anyone bother with the complex setups we have been talking about for the last 2 years?
That is a tough one. I mean, you and I both love tinkering. There is a certain satisfaction in running your own local server, choosing your exact fine-tune, and having total control over the parameters. But let us be honest, Corn, we are the outliers. For 95% of people, if the browser gives them 80% of the performance with 0% of the setup, the DIY scene becomes a very niche hobby, like building your own ham radio. Why would you spend hours configuring Olama or local AI when Chrome or Firefox already has a high-performance model ready to go?
I think you are right, but I would argue that the DIY scene is actually just moving up the stack. Instead of tinkering with drivers and CUDA versions, the new DIY is going to be about building the tools and the system prompts that run on top of these browser-native models. We are moving from the mechanical engineering phase of AI to the interior design phase. We are going to see a massive explosion of small, specialized agents that people build for themselves, knowing that the heavy lifting of the model lifecycle is handled by the browser.
That is a great analogy. I want to go back to something you mentioned earlier about WebAssembly, or WESM. How does that fit into this browser-native future? Because we have seen projects like Transformers.js using WASM to run models in the browser for a while now. How is what Google is doing with WebMCP and the AI Core update different from those earlier projects? That is a crucial distinction. Projects like Transformers.js are amazing, but they are essentially trying to bring the entire library into the browser tab. It is like carrying your entire toolbox with you every time you want to hang a picture. It works, but it is heavy, and it often lacks the direct hardware acceleration that WebNN provides. What we are seeing now with the WebMCP standard is more like the browser providing the tools as a built-in service. Instead of the website bringing the model, the website just asks the browser, "Hey, do you have a model available that can handle this task?"
So it is the difference between a website being a self-contained app and a website being a client for the browser's internal services.
Precisely. And WASM is still the bridge that allows these complex C++ libraries to run at near native speed inside the browser. It is the glue. But the shift is that the browser is now taking responsibility for the model lifecycle. It handles the updates, the caching, and the hardware optimization. This is what we saw with that Chrome update in January. They introduced a feature called AI Core, which is essentially a background process that manages these models across different tabs. It ensures that if you have 3 different websites all wanting to use a summarization model, they all use the same cached instance rather than loading 3 separate copies into memory.
And that is where the second-order effects get really interesting. If every browser has a unique performance profile based on how it runs these models, does that create a new vector for browser fingerprinting? Could a website identify me just by measuring exactly how fast my local llama model generates a specific string of text?
Oh, that is a brilliant point, Corn. I hadn't even considered that, but you are absolutely right. Every GPU has slightly different execution timings and thermal throttling profiles. If a malicious site can run a silent benchmark of your browser's local AI performance, they could potentially create a very accurate hardware fingerprint. It is the classic privacy trade-off. We get data locality, but we might be giving away more permanent hardware ID. The industry is going to have to find a way to add noise to those timing results to prevent that kind of tracking.
It is always a cat and mouse game. But let us look at the positive side for a second. Think about offline-first applications. We have been talking about the agentic internet, but what about the agentic offline web? If my browser has the models cached, I could be on a flight with no Wi-Fi and still have a fully functional AI assistant helping me draft documents or analyze data.
That is the real dream of the agentic smart home too. Remember episode 1073 where we talked about getting away from complex YAML configurations. If your browser is the interface for your smart home and it can run the logic locally, you do not need a cloud connection to tell your lights to turn off when the sun goes down. The browser becomes the local hub. It is a return to the original vision of the personal computer, just with a much more powerful interface.
But I want to push back on the DIY death for a moment. What about the censorship and the guardrails? One of the main reasons people go DIY is to avoid the safety filters that companies like Google or Microsoft bake into their models. If I am using the browser cache model, am I stuck with whatever personality Google decided was safe for the general public?
That is the million-dollar question. Right now, the models being pushed through the Chrome AI core are definitely aligned with Google's safety guidelines. For most people, that is fine. But for the power users, the ones who want a raw model for creative writing or unfiltered analysis, the browser might feel like a cage. However, the Web MCP standard is designed to be extensible. In theory, you should be able to plug your own local model into the browser's infrastructure.
So I could still be a DIY guy, but I would use the browser as my runtime instead of a separate app?
You could point the browser to a local file on your hard drive and say, use this model instead of the default one. You get the benefit of the browser's hardware optimization and the sandbox security, but with your own custom weights. That might be the middle ground that keeps the enthusiast community alive. It is about moving from managing hardware to managing agent permissions within the browser UI.
That would be the best of both worlds. I mean, imagine being able to just drag and drop a GGUF file into your browser settings, and suddenly every AI-enabled website you visit is using your specific fine-tuned. That is a level of customization we have never really seen. It is coming faster than people realize. If you look at the Chrome Canary builds right now, there are already flags for custom model paths. They are clearly building the hooks for this. They know they cannot satisfy everyone with a single base model.
It is funny, we always think of Google as this closed ecosystem, but they are actually being surprisingly open with the Web MCP specifications. I suppose they realize that if they do not set the standard, someone else will. They want to make sure the web remains the primary platform. If AI moves entirely into standalone apps on iOS or Windows, the browser loses its relevance. By making Chrome the best place to run local AI, they are protecting their core business. It is a strategic move to keep us all inside the window.
It is a smart play. Now, let us talk about the practical side for our listeners. If someone wants to start playing with this today, where should they look? You mentioned Chrome Canary. What are the specific steps to see this in action?
Right now, it is still in the experimental phase, but it is moving quickly. You want to download the Chrome Canary build and look for the flags related to Gemini Nano and the Model Execution API. Specifically, look for the AI Model Cache flag. Google is using Gemini Nano as their first cached model because it is small enough to run on almost any modern machine. Once you enable those flags, you can actually go to certain developer demos where the inference is happening entirely on your machine. You can turn off your internet and it still works.
I tried one of those last week. It was a simple text summarizer. I loaded the page, turned off my Wi-Fi, and pasted in a long article. It was instantaneous. No loading spinner, no waiting for a server response. It just happened. It felt like using a local text editor. That was the moment it clicked for me. The latency of the cloud is something we have just learned to accept, but once it is gone, you realize how much it was holding back the experience.
Latency is the silent killer of productivity. When you have to wait 3 seconds for an AI to respond, you use it differently. You save it for big tasks. But when it is sub-100 millisecond, you start using it for everything. It becomes an extension of your thought process rather than a tool you consult. This is how we solve the restart tax. By maintaining persistent context across browser sessions, the AI feels like it is always there waiting for you.
That leads perfectly into the transition from managing hardware to managing permissions. In the DIY era, we spent all our time worrying about VRAM and drivers. In this new browser-native era, our primary job as users is going to be acting as the gatekeeper for what these agents can actually do. We need to start auditing our browser storage settings and looking for these new AI model cache flags.
We are moving from being system administrators to being privacy officers. The browser UI is evolving to reflect this. You are going to start seeing permission pop-ups that say, this website wants to use your local model to analyze your browsing history. Do you allow this? It is the same way we handle location data or camera access now. but the stakes are higher because an AI agent can do so much more with that data.
I hope the browsers do a better job with these AI permissions than they did with cookie banners. If I have to click accept on an AI permission every time I open a new tab, I'm going to lose my mind.
I think that is why the Model Context Protocol is so important. It provides a structured way for these tools to talk to each other. Instead of 1,000 individual permissions, you might grant a blanket permission to a specific agent you trust, and that agent then manages the tools on your behalf within the browser's security framework. It is a more elegant solution, but let us look at the risks for a second. We talked about fingerprinting, but what about model-based malware? Could a website ship a malicious set of weights that, when run by my browser, exploits a vulnerability in the WebNN implementation to escape the sandbox?
That is the nightmare scenario. It is a new attack surface. If you can craft a specific sequence of mathematical operations that triggers a buffer overflow in the GPU driver, you could potentially take control of the system. This is why Google and the other browser vendors are being so cautious. They are essentially having to write a whole new security layer for the GPU. It is not just about protecting the data anymore, it is about protecting the hardware from the model itself. Will browsers eventually become the primary gatekeepers of AI safety, or will they become the next vector for model-based malware?
We are definitely in a vulnerable window right now. That is why I would advise our listeners to be careful with which experimental flags they enable and which models they trust. Stick to the official caches for now. But the potential upside is so high that I do not think we can turn back. The efficiency gains are just too massive. We are seeing the beginning of the offline first web. Imagine a version of Wikipedia that you download once, and your local browser AI allows you to search and interact with it as if you were online. Or a coding environment where the documentation is all local and the AI helps you write code without ever sending your proprietary snippets to a server.
It is the ultimate version of the agentic internet we discussed in episode 855. It is decentralized, private, and incredibly fast, and it is happening right inside the tool we already use for everything else. It really feels like the browser is winning the war for the desktop. For a while there, it looked like mobile apps were going to kill the browser, but by becoming the primary runtime for AI, the browser has made itself indispensable again.
It is a remarkable comeback. And it is all thanks to the plumbing, WebGPU, WebNN, and the Model Context Protocol. These are not the flashy things people see in the headlines, but they are the things that actually change how we use computers. So, looking forward, what are you watching for in the next 6 months? What is the milestone that tells us this has truly gone mainstream?
I am looking for the first major web application to go browser native for its AI features. When something like Google Docs or Notion starts doing its AI processing locally by default for Chrome users, that is the tipping point. That is when the average person realizes they do not need a subscription to a cloud AI service for basic tasks. And that will be a huge blow to the business models of a lot of these AI startups that are just wrappers around the OpenAI API. If the browser can do it for free, locally, why would I pay $20 a month for a wrapper?
The local model is the ultimate disruptor. It democratizes the technology in a way that the cloud never could. It takes the power away from the giant server farms and puts it back on the user's desk, or in their lap. It is a very pro-user development, which I love. It fits right into our worldview of individual empowerment and privacy. We are moving away from the centralized control of the big tech clouds and toward a more distributed, resilient model.
It is a return to form for the internet. A more decentralized approach to technology. It is about giving the individual the tools they need to be productive without being dependent on a central authority. Well, this has been a deep dive. I feel like I have a much better handle on why my browser has been acting so differently lately. Before we wrap up, I want to remind everyone that if you are finding these discussions helpful, please leave us a review on Spotify or your favorite podcast app. It really does help people find the show, and we appreciate every single one of them.
It really does. And if you want to dig deeper into the history of this, check out episode 855 on the agentic internet or episode 633 where we talked about the hardware constraints that led us here. You can find all of that at myweirdprompts.com.
And a big thanks to our housemate Daniel for the prompt today. It really helped us connect the dots on some of these recent updates. It is a lot to keep track of, but that is why we do this.
It is a fast-moving world, Corn, but I think we are heading in a good direction. Local, private, and fast. That is the future of AI.
I will drink to that. Or at least, I will browse to that. Alright everyone, thanks for listening to my weird prompts. We will be back soon with another exploration of the weird and wonderful world of human-AI collaboration.
Until next time, keep your models local and your cache clean. This has been Herman Poppleberry.
And Corn Poppleberry. We will see you in the next one. Take care, everyone.
Goodbye for now.
You know, Herman, I actually forgot to mention one thing about the Chrome AI Core update. They are also working on a way to share these models across different browsers, not just Chrome-based ones.
Oh, really? Like a cross-browser standard for the model cache?
So if you have a model downloaded in Chrome, Firefox could potentially access the same cache so you do not have to download it twice.
Now that would be the ultimate win for the user. No more browser silos.
We will have to save that for another episode, but it is definitely something to watch.
Always more to talk about. Alright, let us get out of here.
See you later.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, my weird prompts, where